Hello guys, myself Ankita. In this video, shall see another problem on LeetCode. So square root of x. So given a non-negative integer x, return the square root of x rounded down to the nearest integer. So the return integer should be non-negative as well. So you must not use any inbuilt or exponent functions such as power or for. All these one cannot be used either in C++, Java or Python. So without using this inbuilt function, we have to solve the problem. So given example, we know like square root of 9 will be 3. If I take square root of 10, what will it be? Near to 10, that is nothing but 3 only. Because 3 3 is a 9, 3 3 is a 9, but 4 4 is a 16. So if you see 9 is the nearest integer present. So that's why square root of 10 will be 3. That is what they have said in the question. So the return integer uh, no, return the square root of the x rounded down to the nearest integer. That is the point. So what is the approach to solve the problem? Usually you can, if there is a number 9, from 1 to 9 you can traverse, and each time check is 1 star 1 equal to 9. If it is equal to 9, just return that. If it is less than 9, then we'll have a variable called result, and that will be 1. Next 2 star 2 you do. How much it is? 4. 4 is less than 9, so result will be 2 now. Next 3 star 3. How much is it? 9. So result you just return 3 now. Okay, if it was 10, so 3 star 3 will be 9. So result will be 3 now because 9 is less than 10. Again 4 star 4 you do. That is equal to 16, which is greater than 10. So you do not know. Then 5, 6, 7, 8, 9, 10. Till there you can do. But you can do that one also. But when the number exceeds the given number, square exceeds the given number, you can stop the loop. That also works. But linear search takes a lot of time. So the other better approach can be, if you see we have a range. The answers come in the range. If you look into the answers, I'll take 9 only. If you look into the answer, that comes in the range 1 to 9. That is for sure. So 1 to 9, in that we have to find a number that is square root of this. So what method comes to the mind? Binary search. When the numbers are sorted and you have all the ranges and you have to search or find something, then binary search comes into the idea to solve the problem. So how do we apply the binary search? Binary search we apply on the answers. So answers ranges 1 to 9. Just write the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have the answers 1 to 9 now. So as you all know in binary search we point, this is a low, or let me say this is left, okay, and this is right, and mid will be left plus right by 2. So 9 plus 1 what will it be? 5. 9 plus 1 will be 10 by 2. That will point to here 5. So now check the mid. Whether 5 star 5, is it equal to 9? No, that is 25. 25 is greater than 9. So if it is greater than 9 means the square root exists before mid. So what you do, right will be equal to mid minus 1. Okay. Now again check. Find out the mid. So mid will be 4 plus 1 by 2, that is 2. 2.5 approximately it will be 2. So mid is pointing here. Now 2 star 2, that is about 4. So 4 is less than 9. So that means there can be a chance to also answer, but the answer will be next to mid now. So low or left will be mid plus 1. So now 3 and 4 you have. So 0, 1, the indexing will write 0, 1, 2, 3. So 3 plus 2 by 2, 5 by. This is the indexing. So if you add these numbers, 4 plus 3 by 2 will be 7, 7 by 2 will be 3.5, that is approximately 3. So mid is pointing here again. Now check 3 star 3. How much it is? 3 star 3 is nothing but 9. That is equal to the given number 9. So you just return the mid now. Return mid. Okay. This is in case if you have the exact square root, then it is fine. What if you don't have exact square root? Let's say the number given is 10 now into 10. So in such case, the answer ranges from 1 to 10. So we'll apply binary search on that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So as you all know, low will right, left, this is left and this is right. And we calculate mid, mid will be pointing 10 plus 11 by 2, 5. So mid is over here. Now check 5 star 5, that is 25, that is greater than 10. So of course right will be mid minus 1. Again compute mid will point here. Okay, so again 2 star 2, that is less than 10. 2 star 2 is 4. So left will be mid plus 1 now. Again compute mid, so mid will point here. 3 star 3, that is 9 less than 10 again. So what happens? Again left will be equal to mid plus 1. So it will point here. So mid will be this time here only. So mid I have written. So this is left. All are pointing to the same position. So 4 star 4 is greater than 10. So right will be mid minus 1. So just take right and it will point to mid minus 1. Now you could see left is not lesser than or equal to right. It is crossing. Right is greater than left. Right is less than left now. So you can stop the loop. So if you actually see the answer where it is pointing, so if you see the answer, 1 star 1 will be 1, 2 star 2 will be 4, 3 star 3 will be 9, 4 star 4 will be 6. So apparently 9 is the answer because the smallest integer present to this. 9 means 3 in the sense. Yeah, in the sense 3. So where which pointer is pointing to 3 here? Right, right? So you have to return that. Why is it happening like that? See, initially left will pointing to the beginning, right will pointing to the end. So this will be the impossible case, this will be the possible case. So when it comes to this part, it will be impossible. This part, when right comes to the beginning of the array, it will be possible answer. So that is how it works. So, okay. And one more thing which you notice here is they're given the constraint on the range 2 power 31 minus 1. So x can be any number. So here when you find the mid, you do mid star mid, right? You check whether it is equal to x or less than x or greater than x. What if the number itself was int max or something near to int max something? So int max was given. Int max number only was given. Then int max will be crossing the integer range. So that's why it will cause an overflow. So we will use long here. Okay. In Java, while returning, you just return int of the whatever answer you have. In C++, long will be automatically typecasted to int, so that is not a problem. So we'll have long left equal to 0 and long right equal to x. So left is pointing first one, not 0. So next, while left less than or equal to right, so first compute mid, that is nothing but left plus right by 2. So once you compute the mid, now check if mid star mid equal to x, then just return mid. And here mid also should be in the long format because this is where it causes an overflow. That's why. So else if mid star mid is greater than x, then right will be equal to mid minus 1. Else left will be equal to mid plus 1 if mid star mid is less than x. So at last, as I said, answer will be pointing to right. So if you find the exact square root, then mid will be answer. Otherwise, right will be the answer. That will be the nearest integer becoming square root of x. So shall run this. Yeah. And for Java, I'll copy paste the same code. So only change which you need to do is at last is written in top right. Why? It's in a long format. Yeah, here also return int of mid. Okay. Yeah, successfully submitted. If you understood the concept, please do like the video and subscribe to the channel. We'll come up with the other video in the next session. Till then, keep learning. Thank you.